Process engineering focuses on the design, operation, control, and optimization of chemical, physical, and biological processes. Process engineering encompasses a vast range of industries, such as chemical, petrochemical, agriculture, mineral processing, advanced material, food, pharmaceutical, software development and biotechnological industries. Process engineering involves translating the needs of the customer into, typically, production facilities that convert raw materials into value-added components that are transported to the next stage of the supply chain, typically packaging engineering, but some larger volume processes such as petroleum refining tend to transfer the products into transportation, trucks or rail, that are then directed to distributors or bulk outlets. Prior to construction, the design work of process engineering begins with a block diagram showing raw materials and the transformations/unit operations desired. The design work then progresses to a process flow diagram, PFD, where material flow paths, storage equipment such as tanks and silos, transformations/unit operations such as distillation columns, receiver/head tanks, mixing, separations, pumping, etc. and flow rates are specified, as well as a list of all pipes and conveyors and their contents. Material properties such as density, viscosity, particle size distribution, flow rates, pressures, temperatures, and materials of construction for the piping and unit operations. The process flow diagram is then used to develop a piping and instrumentation diagram, P&ID, which includes pipe and conveyor sizing information to address the desired flow rates. Process controls, such as tank level indications, material flow meters, weighing devices, motor speed controls, temperature and pressure indicators/controllers, etc. The P&ID is then used as a basis of design for developing the System Operation Guide or Functional Design Specification, which outlines the operation of the process. From the P&ID, a proposed layout, general arrangement of the process can be shown from an overhead view, plot plan, and a side view, elevation, and other engineering disciplines are involved such as civil engineers for site work, earth moving, foundation design, concrete slab design work, structural steel to support the equipment, etc. All previous work is directed toward defining the scope of the project, then developing a cost estimate to get the design installed, and a schedule to communicate the timing needs for engineering, procurement, fabrication, installation, commissioning, startup, and ongoing production of the process. Depending on the needed accuracy of the cost estimate and schedule that is required, several iterations of designs are generally provided to customers or stakeholders who feedback their requirements, and the process engineer incorporates these additional instructions and wants scope revisions into the overall design, and additional cost estimates and schedules are developed for funding approval. Following funding approval, the project is executed via project management. The application of systematic computer-based methods to process engineering is process systems engineering.